Okay, this is our continuation of transformations of linear function. I want to kind of go over the definitions of vertical, compressed and stretched, and horizontal compressed and stretched. All right, vertical. The big thing is remember is vertical means up and down. I mean that's really important that you kind of know that. Horizontal means across, which we'll review a little bit. So when we say vertically stretched, vertically we're looking at the y-axis. Right, so we're really concerned about that y-axis. All right, so here's what we're going to do. When we say we're vertically stretched, okay, so what that means is we take the y-axis, and it's like a rubber band. Think if you have a rubber band, and you have both ends of that rubber band, and you're pulling it up and down. You're taking both ends and just pulling one end up and one end down. When we do this, we're pulling the axis, and when we pull the axis, this line starts to get pulled in like this. All right. And so I'm going to draw a new line, but then the line gets something like this. All right, so if you notice, it gets steeper. All right, so when we say vertically stretched, we are pulling the vertical line and we're kind of stretching it, and it makes the line steeper. So whenever you have something that we talked about before, if we have, remember when we talked about having something like this, or we had this when we had earlier in another video. All right, when we have this and we have numbers in there, so I'm going to just kind of we'll just do one example. I don't have to try to make it fancy for you, but we're going to say, let's say that we have 3 f of x, just something like this. Then that's greater than 1, and because that's greater than 1, we know the line is steeper, and because it's steeper, I've got to think what causes it to make it go steeper. So if I'm asked to look for vertical, I have to kind of think I'm vertically stretching it, all right? And so in that case, that's what we're doing. In fact, in this case, what you see here is the A is outside, and we use the word vertical, all right? So because of the A, the number is outside the x here, the f of x, then or the function of x, or we just say x, then it's vertical, all right? So if I had something that looked like this, just to give you an example, I know that I would be stretching it vertically. If the number was inside with the x, it's touching the x, then it would be horizontal. All right? Because think about it, x is horizontal. It's the horizontal axis. All right. So this is like, remember f of x is y, so we're thinking y vertically. So you really should be using the right term when we say vertically stretched when the number greater than 1 is outside the parentheses like an x. And if it was inside with the x, which I'm going to demonstrate here in a minute, it would be horizontal. All right, so if I change this to a number, closer to 0, so let's make up a number, let's say 1/2. All right. In fact, I'd like to use a different color, so that way when I use a different color, then you can kind of see what I'm talking about. Let's use purple, and maybe that'll help a little bit. So I'm going to clear this off, and we're going to use purple here. And so 1/2. All right, so 1/2 is it's outside the f of x, so we know we're vertically again because f of x stands for y. And so now we got 1/2. And so 1/2 means, all right, what do I do to the vertical axis to make it less steep? And so if you kind of think of the rubber band story again, you have both ends. If you push that rubber band like the ends that you have and push them together, it gets flatter. So I'm going to put it in purple here. It gets, that's a terrible line, but I'm just using an example. So the parent function, it would actually get less steep, all right? So when we say vertically compress, and that's what that means here, stretch means you make it more steep, compress makes it flatter. All right, so I'm going to write that down so you have an idea of what I'm saying in case you missed this. All right, so vertically stretched was in the black, so stretched is more steep. All right, vertically compressed, and think about compress, you're putting it together, and I'm just going to put it that way, it's less steep. So it looks closer to a line. All right, so again, vertical, especially when you have the number outside of the f of x, when we're doing these, if the number is outside the parentheses, it's going to be vertical. So just determining if that number is greater than 1, it's going to be stretched, vertically stretched. If that number, which makes it more steep, it goes like the black line. If it's a fraction or decimal, then it gets compressed. It's vertically compressed. So that'd be just like me taking the y-axis and pushing in on both sides, and like flattening the and making it, and so it pushes that line downward. Downward, like we talked about. It just kind of pushes it downward. We're comparing to the parent function, and so it makes it less steep. All right, so that was vertical. So let's talk about horizontal. All right, and in fact, I can probably use the same one when I go back. We just change the wording here. So I'm just going to go back here and I'll just change this. So now we're going to talk about horizontal. All right, just bear with me. I'm sorry, but this probably would save so much more time if I did it this way. All right, so I'm going to redraw my line here, my graph here, so you can use it, see it as an example. I hope I'm picking the right one. All right, so okay, sorry. And so what I did is I just stopped it and just redrew everything. So now think of this. F of x, remember we talked about this before. This time we're talking about when the number is inside the parentheses with the x. We use the horizontal word. All right, horizontal is the x-axis. Remember vertical was the y. Now we're talking about the x-axis. So we're looking at this guy right here. All right, so we look at this and now we're kind of thinking, all right, what causes this? Let's think about this. If the number, and I'm just going to, like I have up here, I have 3x. All right, that number is greater than 1, so that means the line is going to get more steep. No matter what the number is, in the number, where the number is, if we know it's outside the f of x or inside with the x, and it's a bigger than 1, we know that it's going to be more steep. So what do I do horizontally? That means what do I do to this axis here to make it more steep? Well, it's opposite of vertical. It's really interesting that it's the opposite. All right, so to make it more steep, we're going to compress it. All right, and so we're going to compress. All right, so when I compress it, so otherwise when I push in on these the ends of the axis, this line is going to go up like this. It's going to kind of move in that situation. So my new graph, and I'm going to draw it in black so you can see it, it'll do this again. It'll go right back being steep because I'm pushing in on the x-axis, compressing it. All right. Now, if it's less than 1, like it's a fraction or decimal, then it will be, and I'm going to go back to my original purple. It'll be if we get a number like half of an x. All right, this will make it stretch. All right. And the reason why we say stretch is because what happens here is that the line gets flatter. Remember, anything that gets closer to 0 the line gets flatter. And so because it's inside the parentheses with the x, we have to use the word stretch. So this is going to be horizontally stretched. So instead of taking the x-axis and pushing them in, now we're going to take the x-axis and we're going to stretch them, just like that rubber band we talked about going up and down. Now we're just going to take the rubber band and we're going to go from left. We're going to pull it with both our hands, left and right hand arm, and we're going to pull it apart, away from our shoulders. And so when we do that, the ends of the line start to go in, and it becomes less steep and becomes more flat. So horizontally stretch is less steep. Horizontally compress is more steep. I hope this helps, because that's really important to kind of know those terms.